we're going to learn how to draw a ray diagram for a plane mirror. Plane meaning flat. So this is our plane mirror, P-L-A-N-E. And there are 4 steps to drawing ray diagrams for the plane mirrors. So those are draw the image of the object, and I already did that. So over here is our image. So this is our image. Oh, image. Let me back up. A-G-E. So here's our image, and I try to do dotted lines. It was a little bit haggard, but the idea is that. But the image distance, it's important that you are aware that the object distance from here to here is, we're going to call that, let me back that out. We're going to call that object distance. The object is equal to the image distance. So di, this little line right here, is the same as this side over here. So this distance from the object to the mirror is equal to this distance from the image to the mirror. Okay, so that's important. So when you draw your image, make sure your object distance and image distance are equal here. So important to put that in perspective. Okay, so the next thing is pick one extreme on the image of the object, image of the object, on the image of the object, image of the object. Pick one extreme on the image and draw the reflected ray that will travel to the eye. We're going to put the eye down here somewhere. Let's say here. Oh, that's not a very good looking eye. So let's draw, this is, oh. So that's somebody's eye, right? So we think about this as a, so there's the eye. Okay. Anyway, yeah, I gotta put a little more in there. Just you should be able to breathe. Okay. So here's the eye. We're gonna go from the image. I'm gonna change colors with this. So we're gonna go. Let's make it blue. We're gonna go from the top of the image to the eye. Okay. So that is this step right here. Pick one extreme, top or bottom, on the image of the object and draw a reflected ray that will travel to the eye. So that means we got to realize this is coming from the mirror to the eye. So it's going this direction. Let me back those out. So it's going from the mirror to the eye. And then draw the incident ray for the light traveling from the corresponding extreme. So in other words, from the top of the object, because we went from the top of the image to the eye, now we're going to go from the top of the object and draw a line that meets the mirror at the same place where that intersected. Boom. Okay, so that is our incident ray, and that's traveling in this direction. Okay, so this is the incident ray, and this is the reflected ray. Now repeat steps 2i and 3i for all other extremities in the object. So we're going to go from the bottom. I'm going to draw a different color here. Let's pick goldish. Okay, so we're going to go from the bottom of the image, and we're going to go to the eye, similarly, like we did before, straight line, boom. And then we're going to go from the bottom of the object and meet that line where it intersects with the mirror. Okay? Now, the other important part to understand here is that you have two normal lines. So we have the normal line for each of those rays, the incident ray of the, oh, let me make sure and draw these also in the same. So this is the incident ray, or this is the reflected ray, I'm sorry. Oh, not a circle. We want an incident, boom, boom. That's the direction of the light. Light's traveling from the object to the mirror, and then from the mirror to the eye. So then we also have a normal line that we want to draw for each of those two reflections. So when we do our reflections, we want to reflect those through a normal line, and that normal line is about there. And then the normal line on this one is also, let's make that something like maybe this color. The normal line on this one is, let's say, there. Okay, so this becomes the divider. So if you will, if you understand how this goes, this is the incident ray to the mirror. So this is the incident angle. So this is theta I. And then that means this is the reflected angle, or theta R. Okay, so the incident angle is from the object to the mirror across a normal line. These are called normal lines. And remember we talked about normal force. So the normal is a perpendicular, this is also a normal, perpendicular line. So like a normal force is perpendicular force, right? And it's perpendicular contact surface force. Well, this is a perpendicular line to determine the difference between the incident angle, so we'll call this phi incident, and this is the reflected, and we'll draw that down here as, let me get rid of that, phi reflected. Okay, so this is the incident angle, this is the reflected angle. Law of reflection says the incident angle and the reflected angle should be equal. Okay, so what I had you do is I'm going to have you practice those on the light reflection and mirrors portion. Let me get rid of this. Of the worksheet that I posted from Physics Classroom. So on this first part, it's just saying locate all of the images for the following objects labeled O. So this is an O label for that object. So clearly the image is going to be somewhere the equal distant from this side to this side. So we can draw a line that says, okay, we're going to measure this distance from here to here. And that'll be our object distance. Oh, let me start that again. So this will be our object distance, and then we'll have the same length here for our image distance, and we'll put that in on a different picture. So our image distance will be similar. Equal. This line implies that this is equal to this. So then our image will be out here, and it'll be a little circle. Oh, let's try that again. So then this will be the image distance equal to the object distance. Same thing on this, but if you have an object that's off center, let's say you make sure the object crosses through the mirror. So you want to draw a line that crosses through the mirror. it's important that this distance, whatever this distance is equal to this distance. So wherever you draw your object, blah, 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 make sure this length and this length are equal. Doesn't matter about the angle at that point, just make sure the lengths are equal. So this length is equal to this length. Okay, so then you're going to go ahead and finish the rest of those, and then there's a segment down here about doing the plane mirror and doing the ray diagrams again, same kind of thing. Then it talks about if the object is off center or not quite parallel perpendicular. So then got a couple problems to solve. So straight up, here it is. Okay, so that's the worksheet, and that was the explanation. Good luck. If you have any questions or comments or concerns, please let me know, and I'll see you all on Friday. Thanks.